Alright, so we're still looking at the same thing before, but this time we're going to go for the definite integral. So let me write you out a definite integral so you can see what one is. So I'm going to do exactly the same thing as before. The integral of 3x squared with respect to x. So that's the variable, x is the variable here. But there's a difference now. I've got two numbers here at the top and bottom of the integral sign. 3 and 2. And those are called the limits of integration. Okay? So let me write a note here saying limits. Limits. Integration. And we've got upper limit, lower limit. And what do these limits do and how they're used? Well, later you're going to see what this is used for, and it's something very, very useful. But before that, let's see how we'd go along and calculate one of these. Well, actually we do exactly the same thing as before. We integrate 3x squared, we've got to do the integration, okay? But this time we've got these limits, so we ignore these limits at first. We put them outside of a bracket, a square bracket, okay? Integrate that. We know what happens. It becomes x cubed. We just did it, okay? But you remember how we had a plus c before? We don't have a plus c anymore. That's it. It's finished. There is no plus c. But instead, there are two limits of integration, okay? So the steps are exactly the same as before. You integrate, you add 1 to the power to get 3, then you divide by 3. So this 3 disappears. X cubed, or x to the power 3. Okay? But notice there's no plus c. So when you do one of these definite integrals, you don't have a plus c. But this isn't the answer, okay? We haven't finished yet. What do these things mean, these limits? Well, this is what we do. We take this number here, 3, and we put it into x. So that becomes, we've got x cubed now, so it's 3 cubed. Okay? Okay, so that x, the 3 here has gone into the x there, 3 cubed. Okay? But now look, we've got a lower limit of 2. So that is what we put in for x here. And we subtract that. Okay? So here we've got 2 for x. So we've got 2 cubed. Okay? So you can see what we've done there. We've first taken this number and substituted it in for x, and then we've subtracted and we've put the lower limit in for x. And it's always the same way. You put this number in first and then you subtract this number when it goes in. Okay? But now you just need to evaluate that. So 3 cubed, 27, 2 cubed, 8. 27 minus 8, 19. That's the answer. This is the answer to the definite integral, okay? And that is the big difference. This is a number, okay? This is an algebraic expression that's been integrated with two limits. The limits are then put in and we get a subtraction out of it, okay? So it's always the same thing. The upper limit, subtract the lower limit, okay? And then you calculate that with the actual numerical values and you get a numerical answer, not an algebraic expression. So there, that again, let me state that again, that is the biggest difference, okay? So this with the limits is the definite integral, alright? They're mainly the same up until this bit, when you put the numbers in and you get a number out, alright? So remember again, definite integrals, a number comes out. Indefinite integrals, and that's still here, an algebraic expression comes out, okay? So indefinite, 3x squared comes out. Definite, 19 comes out. 19 is a number. Okay, so in the next video I'm just going to do some practice of that and then we'll do that homework sheet that I set you last week.